Humans aren't so much wrecking the Earth as we are increasing its difficulty setting, at least as far as our own survival is concerned. The planet's going to be just fine. More accurately, we're just finally facing the consequences for everything humans have been doing to artificially lower that difficulty in previous generations. Side effects from all that stuff we've been burning to stay warm, see in the dark, get around, and generally make the world what we wanted it to be has also made it a bit less that. But what if there was a place where those same actions, creating a planet-wide greenhouse effect, introducing invasive species, building stuff all over the place, would actually make a planet more livable, not less? Make it more like the good old Earth. Earthiforming, if you will. Or, when in Rome, terraforming. Terraforming gets its name from the Roman goddess of Earth. Because I can't pronounce Latin, I'm gonna let Google take this one.
Terra. Mater.
Musical. That first word there, terra, was the Latin word for land, territory, or earth as an element, in kind of the alchemy or Captain Planet sense. Terra is the Roman equivalent of the Greek goddess Gaia, and a more literal embodiment of what we might call Mother Earth. Mother's that second word there. The dots I'm connecting here are between Terra and Earth. They're the same place. Actually, most planets in our solar system have Roman names. If we call Earth Terra, it kicks the Roman total for named planets in our solar system up to 7, with the Greeks coming in behind at 1. Oddly, the name Earth is a mishmash of Germanic, Middle English, and some Scandinavian grunty noises, all of which meant the ground, or just dirt. Not home, not mother, not sheltering playground of life. Nope, dirt. Which, if you think about it, makes this the official bumper sticker of potters and ceramists everywhere. Ceramicist. People who make ceramics. It's hard to say. What was wrong with potters? 7 ceramists sipping ceramists sit in Subarus on Sunday. 7 ceramists sipping ceramists sit in Subarus on Sunday. Just like that, I have a new verbal warm-up. In any case, even though Earth is the most common name for humanity's homeworld, at least in English, earth-forming sounds like I'm trying to talk past a mouthful of hot soup while wearing my old orthodontic headgear. So we're going to use the term terraforming when we talk about that process by which humans can make another planet more Earth-like. Terra-like. Moving on. Jack Williamson was the first person to actually use the word terraform in a short science fiction story published in the July 1942 edition of Astounding Science Fiction magazine. Jack Williamson also gets credit for genetic engineering and was talking about antimatter way back when. Martin J. Fogg, on the other hand, gets most of the credit in academics, literally writing the book on terraforming, a word which first appeared in the dictionary in 1993. The main idea here is that on a large enough scale, human actions can alter the environment of an entire planet. And in the last 30 years or so, we've given terraforming researchers all the evidence they need to silence any remaining critics. Literally the world's most bittersweet I told you so. Because we have definitely proved that on a large enough scale, human actions can alter the environment of an entire planet. We're doing it on Earth right now, but calling it terraforming here on Terra is kind of the verbal equivalent of dividing by 0. So when we do it here, we just call it climate change. Or, you know, pollution. But what if we tried this whole climate change thing somewhere else, and on purpose? Using the Earth as an accidental laboratory, we've definitely figured out how to make a planet warmer. When sunlight gets absorbed by objects, some of that energy gets converted into heat. How much light is absorbed is directly related to how much heat an object will then emit. This is why a reflective object, like large ice caps, create less global heating than bare ocean does. Or why leaving your car in 100-degree sunshine and then plopping down on your black leather driver's seat means your kids might get to learn some new swear words. Certain gases, like methane, CO2, fluorocarbons, and nitrous oxide, all do this neat thing in an atmosphere where they trap in the heat energy that a planet has absorbed from sunlight, instead of letting it radiate back out into space. Sort of like a greenhouse traps warm air, which is why we call them greenhouse gases. Putting aside all the nasty implications that greenhouse gases have for Earth, at least we have a handy tool for increasing the average temperature on another planet. provided that planet has an atmosphere, or stuff laying around that we can turn into an atmosphere. But what if the planet is too hot already? What do we do to cool it down? Well, for one thing, if you toss a rock at a greenhouse, it'll definitely get cooler inside because the barrier keeping in all the hot air would be less effective with a giant hole in it. Using that same logic, if we want to weaken the barrier which traps in solar heat, we can do that by reducing greenhouse gas levels in an atmosphere. Scientists and engineers are dreaming up all sorts of ways to do this right now on Earth, perhaps motivated by their collective fear of drowning, starving, resource wars, or just general sadness. Even so, one of the most effective ways to lower greenhouse gas levels on another planet would be to use the naturally occurring CO2 removal units that we have scattered all over the Earth. That is, by planting a few billion trees. But removing greenhouse gases is not our only option if we want to make a planet colder. The whole throw a rock at the greenhouse metaphor has a more literal twist as well. We could actually throw a rock at a given planet to cool it down. The impact of a large enough asteroid would create a nuclear winter effect, minus the nuclear. It would put so much opaque or reflective dust and debris into the atmosphere that sunlight would not be able to get through to heat the surface. We know this works because, well, it also happened on Earth. How many dinosaurs have you seen that don't look like this? Basically, we can either reduce how much solar energy gets into an atmosphere by blocking sunlight, or we can reduce how much thermal energy stays there after it's arrived. So now we have a few tools for cooling a planet down if it's too hot for our liking. Still, turning another planet into a replica Earth is more complicated than just fiddling around with the solar system's clumsiest thermostat. After all, Earth isn't only a set of comfortable temperatures. That said, when we're starting with other planets that present a real danger of making you burst into flames or insta-freezing your eyeballs, a comfortable temperature is a good place to start. And really, I don't mean comfortable for us, at least not at first. Once we've stabilized a global temperature that, at least a lot of the time, allows for liquid water, we can start to populate the biosphere. By introducing specific Earth species, probably heavily modified or selectively bred for the environment that we've created, we can further tailor that environment more to our liking. We might start with some bacteria, or possibly a lichen or other simple plant, something which thrives on toxic gases and produces byproducts that we want, like oxygen. Then we can selectively work our way up a chain of complex life, adding in species which use an existing environmental element while giving off a new one that further changes the existing planet to be more like Earth. The goal for any terraforming project is to eventually be able to walk on the surface of another planet without having to haul around a protective bubble of Earth's atmosphere. Or at least to get as close to that as possible. Obviously, a detailed explanation of how to turn another world into Earth is more complicated than I can explain in a 20-minute video, or at all. But the basic point here is that humans can alter variables on a planet-wide scale. So take any attribute of a given planet, figure out how to fiddle with it, and do the tweaking in a way that makes that attribute more like Earth. Then just work your way down a list of attributes. Might take a while, but how hard can it be? Remember when I mentioned that there are places where you might turn into a human barbecue, or might involuntarily get new contact lenses made of ice crystals? Well, those are the nice planets, or at least some of the easier problems to solve. Here are some others. The hail on the planet is as hard as diamonds, because it's made of diamonds. The gravity is so strong that it turns you into a human pancake, or waffle, depending on where you're standing. Sometimes it rains methane. Sometimes it rains ammonia. It snows sulfur dioxide, which isn't too bad, all things considered, except that that turns to acid when it mixes with the water in your eyeballs. There are some strong winds. The radiation dose you get on the surface is 300,000 times Earth normal. There are huge geysers on the surface, like giant versions of Old Faithful, except they spew liquid nitrogen. There's tidal earthquakes, which is like a normal tide, except in this case we're talking about a shift of more than 200 feet, and we're not talking about the rising and falling of a body of water, we're literally talking about the ground. Or if variety is your thing, you can experience several of these all at once while you fall into a giant psychedelic fractal hurricane many times larger than the Earth. Jupiter, you nut. As you might have figured out, there are places in our solar system that no amount of tweaking will ever turn into anything like the Earth. Actually, for the overwhelming majority of the planets and moons in our solar system, the only way to make them like Earth would be to physically take them apart and then use the materials to build another Earth. Taking apart other planets and asteroids to build custom human habitats on a giant scale might be the only way to, indirectly, terraform Terra. There's really only one way to logically talk about terraforming Terra. There's only one thing that makes that word salad make any sense, and that's to remove the artificial changes that we've made to our homeworld already. Turning the moons of Jupiter into a few dozen humongous habitats, which totals several times the livable surface area of the Earth, would give us the option to move all the people off good old Terra to make it a planet-wide nature preserve. If you want to learn more about the mind-boggling engineering possibilities that we have in our solar system, head over to one of my favorite YouTube channels, Science and Futurism with I.Arthur, and let your nerd flag fly. But don't go just yet, because there are a few planets in our little solar family where this terraforming thing might just work. Between the 8 named planets and the 100+ moons of just Saturn and Jupiter alone, there's a lot of potential real estate in our solar system, even before we count asteroids, minor planets, or the 27 moons hula-hooping around Uranus. Okay, quick tangent, because damn it, if I'm going to make a butt joke, you're going to learn something. Uranus is the only planet in our solar system with a non-Roman name. It was named after the Greek god of the sky, Ouranos, who was Zeus's granddad. The Romans had a different name for Zeus. They called him Jupiter. And Saturn, to the Romans, was Jupiter's dad. Caelus, to the Romans, was Jupiter's granddad, Saturn's dad. Except in this one instance in the solar system, we're not going with Caelus, we're going with Ouranos, or Uranus, the Greek name. Which I think is kind of a bummer, because Caelus is a borderline badass name for a planet. Certainly less snicker-inducing than Uranus. But we almost got something way worse. Uranus came this close to being called Georgium Sidus, or George's star, because the guy who discovered it, William Herschel, thought, hey, you know what? Those other planets were discovered way back when, so it makes sense that they have the names of old gods. But this discovery is a modern one, so we should name it after King George III, who was the King of England at the time. He was also William Herschel's patron, so the guy who paid all his bills. Kind of makes sense. After its discovery, there was nearly a decade of argument, confusion. Another scientist used the same Greek god to name the new element they discovered in a weird show of academic solidarity. But finally, the more popular convention won out, and we were left with Uranus. But because English likes to put the emphasis in a different place than Latin does, instead of uranium, we get uranium. And instead of Uranus, we get the scourge of third-grade teachers everywhere. King George and the Brits weren't completely robbed of glory, though. The moons of Uranus are largely named after Shakespearean characters. So crass collides with class, because the name sounds like... Anyway, even with hundreds of terraforming candidates to choose from, there are very, very few viable options for terraforming in our solar system. After we eliminate all the choices that basically amount to our solar system shouting at us to stay home, there are maybe 4 or 6 options in our solar system where terraforming is even a possibility. And probably not that many. Out of the few that remain, we're going to talk about these 2. Because they're planets, because they're our closest neighbors, but mostly because they're just a little bit lazier than most places when it comes to killing human beings. First up, Mars. Mars offers some handy advantages in our quest to copy-paste the Earth a bunch of times around the solar system. The Martian day is roughly 24.6 hours long. Mars has ice caps where we can find water on the surface. Mars is even tilted on its axis only a little bit more than the Earth is, meaning Mars goes through yearly seasons, just like the Earth does. Okay, not just like the Earth does. At the moment, Mars has an average temperature of around negative 63 degrees Celsius. The lowest temperature ever recorded in the contiguous US was roughly negative 57 degrees centigrade at Rogers Pass, Montana in 1954. Which isn't really a surprise to me, but I grew up in Montana. Here's a picture of me with my eyes freezing shut in below zero wind. I took this picture in April. There's not really a point to this, I'm just discouraging people from moving to Montana. Okay, there's kind of a point. Negative 63 degrees centigrade is really, really cold, and that's the average temperature. While the highs on Mars can reach up to 35 degrees, the lows can plummet all the way down to negative 143, which is cold enough to freeze butane. So, bit of a range. No big deal though, we know how to fix this, right? Trees and CO2 and throwing rocks at greenhouses and all that. Well, we know how to change it. Fixing it enough to allow a person to visit a Martian nude beach is something else entirely. There are a few aspects of Mars that make terraforming problematic. The big one is the atmosphere. Mars doesn't really have one, at least not compared to Earth. The air on Mars is composed of around 95% CO2, which is great for trapping in all that heat that we're going to need, except that the atmospheric pressure of Mars is only 0.6% of Earth. At its most dense, Martian air is the equivalent of being 35 kilometers above the Earth's surface. That low pressure doesn't allow the air to heat up much. It also means any ice that gets hot enough to melt skips the liquid stage and turns right into vapor. Worse still, even if we went through the monumental task of thickening up the air on Mars, it wouldn't be a permanent fix. As far as we can tell, Mars used to have a decent atmosphere, and maybe even liquid water on its surface. Then Mars lost its magnetosphere, and its atmosphere got blasted into space. That last bit is a lot of information to absorb in a single paragraph, so let's recap. Energy shields are real, the Earth has one, Mars used to have one, but lost it somehow. And that was a really bad day for anyone whose favorite color isn't red. The energy shield I'm talking about is actually a magnetic field. It's a thing on Earth that solar particles bounce off to create beautiful auroras near the poles. Earth's magnetic field is generated by convection currents in our nickel-iron core, the same thing that causes our tectonic plates to shift around, which in turn cause volcanoes. And Mars has none of this stuff. To be fair, Mars actually had the biggest volcano in the solar system, Olympus Mons, which is twice the height of Mount Everest. But as far as we can tell, Mars currently has no volcanic activity whatsoever, meaning no churning core, meaning no magnetosphere, meaning no shielding for the planet or its atmosphere. As a result, every time the sun burps out a solar flare, Mars takes it full in the face. The constant barrage of protons and other particles that the sun flings into the rest of the solar system is informally known as solar wind. This solar wind slams into Mars, and with no magnetic field, there's not much to stop it from blowing the Martian atmosphere right off into space. The lack of a magnetic field also means the average yearly radiation dose on Mars would be around 13 times what we'd get on Earth, roughly equivalent to smoking 11,000 cigarettes, or a pack and a half a day for a year. But like temperature, because in the case of radiation we're talking about an average, there are also some more extreme circumstances that can happen. If you happen to be outside on the Martian surface during a solar flare, you could get more than 3 times your yearly radiation dose in a single day, or roughly equivalent to taking 186 chest x-rays, and about 40% of the maximum dose allowed for US nuclear workers in an entire year. There's a few other things that make Mars a difficult terraforming candidate. For one, there's the insidiously nanoscopic dust on Mars that will invade literally everything. There's the chronic effects of a lower gravity field on any life that we might bring there. There's the lower solar energy output because Mars is farther away from the sun. But the kicker is a NASA study from 2018, which notes that even if they converted every eligible material on Mars that could possibly turn into CO2, they'd only get the atmospheric pressure from a paltry 0.6% of Earth's to a whopping 7-ish% of Earth's. No terraforming job is ever going to be practical. But between the lack of an atmosphere and a lack of a magnetic field, can we terraform Mars? Sure, you can shout at a moose to get out of your way. It might even move a little bit. But probably you'll just wear yourself out and nothing else will happen. Unless you get impatient or overconfident, in which case you will definitely die. I should mention that NASA does have a proposal which would provide Mars an artificial magnetic field, but it's such a huge project that it would be simpler to just live in orbit of Mars on platforms that can simulate normal gravity. So if Mars is out, what do we have left? In part 2 of this series, we'll be talking about the seething hellscape that is Venus. But don't go just yet. Yes, you. Because I would like to borrow a moment more of your time, if you please. Right now I'm experimenting with episode length, and if you're watching this, your opinion is important to me. Here's what's up. I shot the entire script for this topic and it came out to about a 35-minute episode. It takes a lot longer to edit a 35-minute video than it does a 17-minute one. So in this case, I'm releasing this topic as 2 episodes, each one released as soon as I finish the editing. What I'd like to know from you awesome people is whether you'd rather have a topic come at you all at the same time, even if it takes me 3 weeks to edit, or if you'd rather see me break these larger topics into smaller chunks so you can get a video every 2 weeks or so. Please sound off in the comments below. I'd really like to hear from you. Finally, last thought, after much badgering from a few of you, A Better Question has a Patreon page, which means I get to say the following. If you feel like supporting the channel, the link is below in the video description. But also, thank you to these wonderful people for contributing. Like the atmosphere of Mars, I'm blown away. Please share any other thoughts you have in the comments below. I'm relatively new at this, and they really do help me make better content. Make requests, tell me what you liked, tell me what you hated. I ain't scared. But if you did like this video, please show it by clicking the button. And if you feel that I've earned it, please subscribe. As always, thank you for watching, and I'll see you next time.